Today we're going to talk about the octet rule, ions, and oxidations. So if you'll recall from Unit 2, when we talked about the arrangement of electrons in an atom, electrons order in from the lowest energy level and the lowest subshell in an energy level. And the outer highest occupied energy level are called valence electrons. Remember, elements want to have 8 valence electrons in their valence shell, except for hydrogen and helium, which can only hold 2 because that's an s orbital. Remember, after atoms have 8 valence electrons, they begin a new quantum energy level or a new period. So they are actually unstable on the periodic table the way they are written and where their electrons are, except for the noble gases, which have 8. So they tend to gain or lose or share in order to have that 8. And they gain, lose, or share based on their properties and their trends that we studied earlier. So these gaining and sharing of electrons can create what are called ions. Ions are atoms that have different numbers of electrons. The charge of an ion is equal to the number of protons minus the number of electrons. If you'll recall, atoms are neutral because they have equal numbers of protons and electrons. Protons are positively charged, electrons are negatively charged, so 10 minus 10 equals 0. But if you have 10 minus 9, you have plus 1. Or if you have 10 minus 11, you have minus 1. The charge is often called the oxidation number. We use oxidation numbers to help us write chemical formulas and chemical names and balance chemical equations. So this oxidation number, you're going to have to know this and use this periodically throughout the course. So some general rules of oxidation numbers that we're going to go with for now and revisit again later are, these are the positive or negative charge on a monoatomic ion. The number on a pure uncombined element is 0. The oxidation number on a monoatomic ion is equal to the ion's charge. The oxidation number of group 1 metals in a compound is always plus 1. The oxidation number of group 2 metals in a compound is always plus 2. And the oxidation number of aluminum is always plus 3. The oxidation of fluorine is always negative 1. So on your periodic table, you'll want to figure out a way to note this or come back to this page, or I'll put it in as a resource sheet as we go through this unit and future units. But you'll want to mark, in addition to valence electrons, you'll want to note that group 1 elements have plus 1 oxidations. Okay, group 1 have plus 1 oxidations. And then group 2, all of these have plus 2 because this has 1 valence. If it loses 1, it becomes a plus 1 ion. So this has 3 protons. If it loses 1, it has 2 electrons, so it's plus 1. So 3 minus 2 is plus 1. And again, 2 valence electrons, loses 2, so it has an octet. And it's 2 valence, so 4 minus 2 equals 2. We skip the transitions. Coming over here, most elements in group 3 form a plus 3. Most elements in group 4, plus 4. Then we start gaining electrons with the nonmetals, because at this point we have half of the 8 valence electrons. And energy-wise, it's easier now to gain the few rather than lose more. So in nitrogen group, we end up with negative 3. So to have 8, so 7 plus you end up with the 5 valence here, plus 3 is 8. And then you have with 6 valence plus 2 is 8. And 7 valence plus 1 is 8. And then all of the elements in the noble gas group are neutral and don't have any reactivity unless we force them. Chemical bonds can be classified by 3 ways. Ionic bonding, which is the electrostatic attraction among ions because opposite charges attract, which are formed from the transfer of one or more electrons from one atom to another and form between usually a metal and a nonmetal. Covalent bonding results from sharing of one or more electron pairs between two nonmetals. So ionic bonds form when cations and anions, you have the metal losing electrons, nonmetal gains them, now you have a cation and an anion, they're oppositely charged, now they are neutral when they form a bond, and that's between a metal and a nonmetal. Two nonmetals will share pairs of electrons. And then you also have metallic bonding. Well, in metallic bonding, you have the delocalized electrons and the metallic cations, and these electrons are free to move, form between metal atoms. So when copper bonds with other copper atoms, those valence electrons in the d orbitals move like in a C, and that's what electricity is the movement of electrons in bonded metal atoms. That's how we get electricity.